In this video, we'll be discussing about the most popular 4 networking concepts in Azure. We'll not be learning just the concepts, but we'll also implement them hands-on in real time using one of the most widely used tools today, which is Databricks. So firstly, to begin with, let's discuss why a data engineer should learn the networking and the infrastructure concepts. So the reason for this is, when you work as a data engineer on a real-time project, especially with the public or the sensitive data organizations, the first thing you need to make sure is about how secure you are building the data platform. This can be achieved by deploying the platform with a well-architected networking setup. Many aspiring data engineers make the mistakes of only learning the tools and the concepts and then stepping into a company without any understanding of how to properly secure and maintain the platform they are building. This is something that most YouTube videos and even in-depth courses don't actually cover. I believe every data engineer should have a clear understanding of this. In fact, in senior level data engineering interviews, you'll almost certainly be asked about the networking concepts. And having this knowledge will help you clear those interviews with ease. Okay, without wasting further time, let's get started. So before jumping into the 4 key networking concepts, let's step back and talk about why networking is such a critical piece of a data platform in the first place. Networking controls how resources talk to each other, who can access them, and whether the traffic goes securely through the private channels or over the public internet. It's the base that makes your platform not only work, but also stay secure, reliable, and compliant. Without proper networking, even the most advanced data platform can be exposed to risks like unauthorized access, data leaks, or performance bottlenecks. So that's why, before learning the tools or building pipelines, every data engineer needs to understand networking fundamentals because they directly affect how well the platform is protected and how confidently it can handle sensitive workloads. Okay, now let's discuss the 4 important networking concepts in Azure, which are virtual network, subnet, private DNS zone, and finally private endpoint. These 4 are the foundation of networking in Azure, and together they form the base of how you build a secure and well-structured data platform. And here are the definitions for all 4 concepts. Now, these definitions are easy to find anywhere online, right? But the real problem is, without hands-on practice, it's very hard to actually understand them. That's why, in this video, the focus will be more on the hands-on part. Once we see them in action, we will circle back to these definitions so they'll make much more sense. Okay, now, as always, I'd like to start explaining these 4 concepts with an analogy to understand these concepts easily. So let's see what is that. Consider there is a big scale IT company. It could be any company, and if you have worked in a large scale organization before, you can imagine something like that. The company usually has its own premises, right? Which is the entire area of the IT company. This company premises is a private space, and only employees of the company can access it, whereas the public cannot simply walk in and make use of it. And now let's imagine inside this IT company premises, there are many buildings. For example, one building could be the development block, another could be the HR block, and also there may be a food court or other buildings as well. All of these together form as the IT company. So as discussed now, let's keep 2 things in mind. There is an IT company as a whole, and there are multiple buildings inside it. Okay, now let's add something interesting to this picture. Imagine there is a playground next to the IT company. This playground is outside the premises. It does not belong to the company. The playground is open to the public and has a public path, and anyone can use it, not just the employees. So if the employees of the company wants to go to this playground, they must leave the company premises and go through the public path. And now let's imagine one thing. The employees of the IT company doesn't feel safe about this. They don't want to leave their secure space and use a public path just to reach the playground. So therefore, the employees and the management discuss internally and decide why not build a private path directly from the company premises to the playground. That way, only employees can use this private path and they don't need to depend on the public route. Now imagine this private path has been constructed, and from now on, when employees need to go to the playground, they can take the secure private route instead of going through the public road. But imagine there is one more issue. Since the private path is new, employees don't know exactly where it is located, how to use this private path, and its security requirements, such as the key or the access card details. They need someone to guide them. So, for this, they go to the receptionist. The receptionist has a directory of all the paths and location of the entire company. The employees reach out to the receptionist and ask, where is the private path to the playground and what are the security requirements to use it? The receptionist tells them the details, and with that information, they follow the private path and safely reach the playground. So, one thing to be clear, this is just an imaginary scenario. It doesn't exist in the real world, but I'm using it here as just an analogy to explain the networking concepts. I hope that makes sense. Okay, now let's come to the interesting part. In this scenario, you can think of this entire IT premises as a virtual network. A virtual network works just like an IT company in this scenario, which means that it is a private space where only authorized resources exist and can communicate with each other. So in the cloud, we can configure this private space by creating a virtual network. Okay, now as discussed earlier, we may have multiple buildings inside a company, and these buildings can be replaced with something called subnets. Say, for example, the dev block can be replaced with subnet 1, and the HR block can be replaced with subnet 2. So basically, a subnet is simply a way to divide a larger network into smaller, more manageable sections. This allows you to configure rules, apply security controls, and manage traffic separately for each subnet. Think of it having a different departments inside the company premises, each with its own boundaries and policies. So that's what exactly subnet does in a virtual network. Next, let's consider the receptionist from our analogy. This receptionist can be replaced with private DNS zone. So firstly, what is a DNS? As you all know that every system on the internet is identified by an IP address, right? But the problem here is IP addresses are just long strings of numbers and they are difficult to remember. That's where DNS or domain name system comes in. DNS acts like the internet's phone book, giving us easy to remember names instead of numbers. For example, it's simpler to remember google.com but not the IP address behind it. When you type google.com in your browser, DNS takes that name, look up the corresponding IP address, and then directs your request to the right server. In other words, DNS does the translation for you, so you only have to remember names, not numbers. The private DNS zone in Azure works in the same way, but it's used inside your private network. It ensures that when your resources in your virtual network try to connect to a service, they don't go out to the public internet. Instead, DNS resolution happens privately, mapping the service names to its corresponding private IP addresses. This makes communication both easier and more secure. So if you're feeling a bit confused, don't worry about it. We'll be implementing everything step by step in the hands-on section with Databricks. So for now, just try your best to understand the concepts, keeping the analogy in mind. Alright, so far we have seen three things: the virtual network, subnets, and the private DNS zone. Now, let's discuss our final networking concept, which is private endpoint. So here in this diagram, we can replace this private path with private endpoint. So basically, this private endpoint is used to communicate privately with any external services without exposing to the public internet. So remember the playground in the analogy, right? This represents any external services like an on-prem SQL Server database or any cloud-based service like Azure Storage Account, Azure SQL DB, or even the Databricks control plane. So by default, these services are accessible over the public internet. A private endpoint solves this by creating a secure private path between your virtual network and the external service. This means your resources in the virtual network can talk to the service directly over the private network without ever exposing traffic to the public internet. Okay, so to summarize these four concepts with our analogy, virtual network is similar to the IT company premises. Subnets are the individual buildings inside the company. Private DNS zone is the receptionist who tells you the exact location of the private path and the security requirements. Private endpoint is the private path that lets you securely access the external services. Together, these four concepts, virtual network, subnet, private DNS zone, and the private endpoint, form the foundation of networking in Azure. Okay, I hope that you have understood the concepts. And now let's move on to see how to implement them in real time. We'll configure this step by step using Azure Databricks, which is one of the most widely used tools in Azure data engineering. By the end of that, you'll have a clear hands-on understanding of how networking actually works in real time. So let's jump into the Azure portal and see how we can implement this. Okay, now I'm in the Azure portal. First and foremost, what we are going to do is, let's create a new resource group specifically for this tutorial. After doing that, we can create all the resources required for this tutorial inside that resource group. So for that, here you'll find a resource groups option. Let's click on it. After clicking, you'll find a create option in the top left. Let's choose this. And here, firstly, we need to give the name of the resource group. I'm going to name it as RG Private Network 01, where RG stands for resource group. After that, we need to configure the region. You can choose your closest region. I'm going to choose Australia East. After selecting this, we can go to the next step. And here we have tags, which are optional, so we can ignore them. After that, let's go to the next page and click on Create. Okay, as you can see here, we have created the resource group. Okay, now let's click on Go to the resource group button. Nice. So this is a resource group we would use for this complete tutorial. Okay, now let's discuss what we are going to do as part of this tutorial. Inside this resource group, we'll create two Databricks workspaces. One workspace will be created without any networking configuration, and another workspace will be created with networking configurations enabled using the four concepts we discussed earlier. After creating them, we'll do some testing in both the workspaces, compare the results, and understand exactly what happens in the background. Okay, firstly, we'll create a Databricks workspace without any networking configurations enabled. So for that, let's click on the Create Resources button here. After clicking it, we can choose the Azure Services Only checkbox. And then if you scroll down, you'll see the Azure Databricks service. And here let's click on the Create button. Okay, firstly, let's make sure to choose the correct resource group, the one we just created. And next, there is an option for the workspace name. So I'm going to give a name like DBW without private network 01. This is just to indicate that this Databricks workspace is created without private networking. And after creating that, we have the region. So I'll go with the same Australia East as same as the resource group. And next for the pricing tier, we can go with the recommended premium option. Okay, now we have finished the basics tab. Next, let's look at the networking tab. So among everything, this part is the one which is very important. Here, you'll find an option called Deploy Azure Databricks Workspace in your own virtual network. As you can see here, by default, this option is set to No, which means by default, there is no networking configurations enabled for the workspace that we are creating. So when we need to create a workspace with the networking configuration enabled, we need to choose Yes for this option. So since for this workspace, we are not doing any networking configuration, let's go with the default option as no. And once this is done, let's go to the next tab, which is encryption. So this is completely optional to configure. So let's skip this and go to the next tab, which is security and compliance. Okay, for this tutorial, we can skip this part as well. This tutorial is focused only on the networking concepts. So we are not configuring any encryption or security as part of this. So let's go to the next tab, which are tags. So as discussed earlier, we can skip this as well. And now, finally, let's click on the review and create button. Nice. As you can see here, the validation is successful. So now let's click on the create button. Okay, the workspace is now being created. So let's wait for it to complete. Nice. As you can see here, we have created the Databricks workspace. So here you'll find a go to resource button. So let's click on it. And from this page, let's click on the launch workspace button. And this will take us to the Databricks workspace that we created. Okay, we are now inside the Databricks workspace. And here, the first thing we'll do is create a compute cluster. So as said earlier, firstly, we are going to perform the testing in this workspace, which has no networking configurations enabled. So for that, under this compute section, let's click on this create with personal compute option. Here, I will change the cluster name as test private network. And after giving the name, we can also adjust the auto termination setting to reduce the idle timeout. So I'll give something like 15 minutes. And once that is done, we can click on this create compute button. Okay, so while the cluster is being created, in the meantime, let's go back to the workspace and create a new notebook. So after creating it, firstly, let's rename the notebook to something like private network. Okay, once this is done, we can now perform the test. So for that, we are going to write a small script. It's just a simple shell command. So here in the first cell, I will type %sh, which means that it is a shell command. And here, I will type a keyword called nslookup. So I'll explain shortly what we are trying to do here. Firstly, let's focus on the testing. Now in this URL, we'll have our workspace ID. So let's copy the workspace ID and paste it next to the nslookup command. Okay, so this is our complete code for performing the test. So for running the script, let's first attach the cluster to this notebook. And once this is done, let's try to execute the cell. As you can see here, the cluster is still spinning up. So let's wait for the cluster to execute the cell. And then we can see what output the code produces. Nice. As you can see here, this is the output that we got by running our test script. Here, the most important thing that we need to note here is the canonical name, which we got as australiaeast.azuredatabricks.net. And another most important thing is IP address, which we got as 4.147.241.0. So basically, what we are doing here is running the nslookup command, which stands for name server lookup. The purpose of this command is to resolve a server name into its equivalent IP address. In our case, we pass the Databricks workspace URL ID into nslookup, the script that returns the canonical server name along with its corresponding IP address. So that's what we got as an output here. Now, let's discuss why we are doing this test and what this output actually means. So to understand this better, we need to understand the Azure Databricks architecture first. So for that, in the new tab, I have opened the official documentation about the Azure Databricks architecture. Okay, as you can see here, this is the Azure Databricks architecture. In this architecture, there are two main parts, the control plane and the classic compute plane. And here, the control plane is managed entirely by Databricks. It does not exist in our Azure subscription. It is hosted in a Databricks managed subscription. On the other hand, the compute plane is where our Spark clusters run, and it is deployed inside our own Azure subscription. Here, we manage the infrastructure, networking, and access for the clusters. So to repeat, the control plane is managed by Databricks, while the compute plane runs in our own environment and it is managed by us. Okay, now as part of our testing, in this notebook, we created a Spark compute and ran this script. Now, here's the key part. When we run the nslookup command, notice where that command was executed. It was inside our compute cluster. That means the request originated from the compute plane. So when this happens, what this typically means is the request originated from our cloud account, which is from the compute plane to the control plane. Here, the compute plane is nothing but the Spark cluster that we have created. And from this script, the compute plane takes the workspace URL we passed in and sends a request to resolve it. And that URL, which is the Databricks workspace ID, actually belongs to the control plane. What this means is, this entire UI of this workspace is hosted by the Databricks in the control plane. So the compute plane is essentially asking, where is the control plane for my Databricks workspace? What IP address should I use to reach it? And for that, this is the output that we got, which is 4.147.241.0. And this IP is a public IP, which means that the communication between the compute plane and the control plane happen over the public internet. So the reason why I am saying this IP is a public IP is, here in another tab, I have opened an official Microsoft documentation, which is about the list of IP addresses and domains for the Azure Databricks services and assets. And here, if you scroll down, you'll find the Australia East region. And in this, we can see the control plane IPs, which also indicates the web app. And for this, the documentation has the public IP range. And here you can see the IP 4.147.241.0/28. So this is the exact IP we got as an output in the notebook. And as you can see here, this IP is a public IP. So while creating this Databricks workspace, we created it in the Australia East region. So all the control plane infrastructure is hosted in the Australia East region. So when we try to communicate with the control plane from our compute plane, the communication will happen in any one of these available public IPs. And in our case, it happened with the public IP 4.147.241.0. So this confirms that at the moment, any communications to the control plane will happen through the public internet. And this is a problem we are going to address as part of this tutorial. So for the business critical platform, it is very important that all the inbound and the outbound communications happen through the private network. So to address this, we'll create a new Databricks workspace with all the private networking configurations enabled. And then in that private network enabled workspace, let's perform the same test and see what output we are getting for that. Okay, let's see how we can do that. So firstly, let's go to a resource group, which is RG Private Network 01. And here you can see just a Databricks workspace which we created earlier. And this one doesn't have a private networking configurations enabled. Okay, now we are going to create a new Databricks workspace with private configuration enabled. This means that we are going to deploy a new Databricks workspace in our own virtual network. So for doing that, the first and foremost step is to create a virtual network before actually creating the Databricks workspace itself. So usually companies would have their virtual network created. And in that case, we can use that virtual network to deploy our Databricks workspace. But since we are doing all the setup from scratch, we need to first create the virtual network. So we have already seen the concept of virtual network, and now we are going to create it in real time. So for that, let's click on this create button. And here, let's check this Azure Services Only checkbox. And once you do that, you can find the virtual network service over here. Okay, now let's create the virtual network. Okay, firstly, let's make sure we have selected the correct resource group where everything will be deployed. And once that is done, here we need to give our virtual network a name. I'm going to name it as VNet DBW01. Okay, so this is our virtual network name. And once the name is given, let's choose the same region as Australia East. Okay, now let's go to the next tab. And this tab is only focused on the security configurations. So as discussed earlier, this tutorial is only focused on the networking part and we can ignore the security aspects. So therefore, we don't need to modify anything here and can move on to the next step. Okay, so here we are in the IP addresses tab, and this is the most important one. As per the example we discussed earlier, the outer boundary, which is the entire IT premises, represents the virtual network. And inside that virtual network, we had multiple subnets. So this is the place we are going to create our subnets. And here, by default, you'll see a single subnet created automatically. Let's delete that for now because we want to configure our own subnets for Databricks specifically. Okay, now to create the subnets with respect to Databricks, we need to recall the architecture we discussed earlier. So now we all know that the control plane is managed by Databricks and the compute plane runs inside our subscription. So when we deploy a Databricks workspace in our own virtual network, we need two subnets, one for the public communication and the other one for the private communications. So basically, the public subnet is used when the workspace needs to talk to any external services outside the virtual network. And the private subnet is used for the communications within the virtual network for workloads running inside our own subscription. So in this case, the public subnet is mainly for the control plane communications since it exists outside our subscription and it is completely managed by Databricks. On the other hand, the private subnet is for the compute plane which runs inside our own subscription. So in Databricks terminology, the public subnet is called the host subnet and the private subnet is called the container subnet. So basically, we are now going to split the virtual network into different subnets. So for that, let's click on this Add Subnet option. After clicking it, firstly, let's remove the default name. And I'm going to name it as DB host. Here DB stands for Databricks and host indicates it's a public subnet. And this public subnet is used for the control plane. So that's the main concept here. Okay, after giving the name, here you can see the IP addresses range assigned automatically. So basically, for this subnet, the default configuration has the range which includes 256 IP addresses. So these IP addresses can be used for the communications, and this 256 IP should be enough for our setup. And once this is done, there is one more important thing we must configure. So if you scroll down, you'll find something called subnet delegation. So this option basically means that you are assigning this subnet to a particular service completely. So here we need to delegate this subnet completely to the Databricks workspace. So the reason for that is, as discussed earlier, the public subnet is for the control plane communications, and that's the reason we need to delegate the subnet entirely to the Databricks workspace. So when you do this, the Databricks workspace can use this public subnet for its control plane communication. So for configuring the private network for Databricks, two delegation must happen. One is for the control plane and the other one for the compute plane. So now we have done for the control plane with our public subnet, which is the DB host. And now let's do the same for the private subnet. So let's add a new subnet, and this time let's name it as DB container. As mentioned earlier, this one represents our private subnet for the compute plane. Again, let's go with the same IP address range, which is automatically assigned. And after this, let's scroll down and go to the subnet delegation and delegate this subnet to the Databricks workspace and click on the Add button. So what we have done so far is, as part of this virtual network creation, we have created two subnets, which are DB host and the DB container. Here, the DB host is the public subnet and the DB container is the private subnet. So basically, the DB host is used for the control plane communications. So since it is hosted and managed by Databricks, it will be outside the virtual network and we need a public subnet to communicate with it. And the DB container is mainly used for the compute plane communications, which exist inside our own virtual network and managed entirely by us. So that's the reason we have delegated the private subnet for it. In addition to these two subnets, we need to create one more subnet. And this is the subnet that will be used for the private endpoint creation. So what I mean by this is, let's create a new subnet. And this time, let's name it as private endpoint. And for this subnet, we don't have to delegate it to any service. This subnet will be used later for all the private endpoints we want to connect. So don't worry about anything right now. Everything will make sense once we complete this tutorial. So now, in total, we have three subnets created. The DB host, which is the public subnet for control plane. And then we have the DB container, which is the private subnet for compute plane. And finally, we have the private endpoint subnet, which is for the actual private endpoint connections. So when you compare this with our example, we have the dev block and the HR block, right? So we have just created it, but in this case, we have three subnets instead. Okay, once all these are created, let's click next. So the tags are optional, so we can skip them. Now let's go to the review and create tab, and then click on the create button. Okay, as you can see here, the virtual network is getting created. So let's wait for it to complete. Nice, we have successfully created the virtual network. So let's click on the go to resource button. As you can see here, this is our virtual network, and here on the left side, you'll find an option called subnets. If you click on that, we can see all the three subnets we just created along with their allocated IP addresses range. Also notice that the first two subnets, which are the DB host and the DB container, are delegated to Databricks, while the third one, which is the private endpoint, is not delegated to any service and will be used for private endpoint connections later. So we will see how we are going to use these subnets and stuff. But before that, one interesting thing to note here is all the IP addresses we have here starts with 10 dot. So usually any IP that starts with 10 means it is a private IP addresses as per the IP version for private address range. So if you have studied computer networks in your college, you may recall that IP addresses starts with 10 falls under Class A private IP range, commonly used for internal networking. Say for example, I have opened the Wikipedia page in another tab, which is about the private network. And here, this is the IP addresses range that we have configured for our virtual network. And this one comes under the class A network, and all the IPs belongs to this class starts with 10. And with this, you can have these many unique IP addresses that you can use inside your virtual network, which is really massive. And among these available IP addresses, we are just using 251 IPs per subnet, which is more than enough for most of the data platform. But the exact number of IP addresses you need completely depends on the size and the usage of your platform. I hope that makes sense. Okay, so we have created the virtual network and also configured three subnets inside the virtual network. So what's the next step? If you remember as per our diagram, the next step is to create the private DNS zone. So let's see how we can do that. So for that, what I'm going to do is, let's first go to resource group. And now here you can see that we have the Databricks workspace we created earlier and the virtual network with all the subnets we configured. As mentioned earlier, the next step is to create a private DNS zone. To do this, let's click on the create button, and here in the search box, let's search for private DNS zone. As you can see here, this is the private DNS zone that we need to create. So let's go ahead and create it. Okay, here, firstly make sure you choose the correct resource group where all our resources live. And once that is done, the most important thing here is the name of the private DNS zone. Here, you cannot give any name as per your wish. So to understand this better, firstly, we need to understand why we are creating this private DNS zone in the first place. The main reason is that we need a way to resolve the control plane URL of Azure Databricks into a private IP address. By default, this URL resolves to a public IP, and this is what exactly tested previously with a notebook. But we want to make sure all communications happens privately over the Azure backbone network. So for doing that, the private DNS zone name must follow a specific format provided by Microsoft. So what I mean by this is, in another tab, I have opened the official Microsoft documentation for Azure Private Endpoint Private DNS Zone Values. Here in this document, if you scroll down, you'll find the entries for Azure Databricks workspace. In this table, you can find the public DNS zone and the private DNS zone name values. So if you look at the Azure Databricks workspace row, The public DNS zone for Databricks is AzureDatabricks.net, while the private DNS zone for Databricks is privatelink.azuredatabricks.net. So in order to resolve the control plane URL of Azure Databricks into a private IP address, we must create the private DNS zone with the name as exactly privatelink.azuredatabricks.net. So let's copy this value and paste it over here. So basically, this is mandatory because when our clusters inside the VNet try to reach the Databricks control plane, the DNS resolution should happen privately using this private DNS zone instead of going to the public internet. So that's the reason we are using the private DNS zone, and Microsoft expects to have this exact name for the private DNS zone. I hope that makes sense. Okay, after giving the name, let's go to the next tab. So this one is about the private DNS zone editor. Here we don't need to change anything in this tab. So let's go to the next one, which is the virtual network links. This one is important. So here you can see a button called Add Virtual Network Link. So let's click on it. After clicking this, firstly, we need to give a name for this VNet link. So I'm going to name it as VNet link DBW01. So basically, what we are trying to do here is, we are trying to link this private DNS zone that we are creating with our virtual network that we have already created. So only when we do this link, the virtual network will be able to use this private DNS zone for name resolution. So when you remember our example diagram, there was a link from the subnet to the receptionist, right? So that's what we are trying to do here. So to do that, we need to select our virtual network here. So for that, let's choose the correct subscription and select the virtual network we created earlier, which is VNet DBW01. After selecting it, click on the Create button. Okay, so now we have created a link between the private DNS zone and the virtual network. Okay, so the next one are tags, which are optional. So we can skip that and go to the final review and create page. So here you can see the validation for all the information given are successful. So let's go ahead and click on the Create button. As you can see here, the private DNS zone is getting created. So let's wait for it to complete. Nice. So we have successfully created the private DNS zone. Let's click on the Go to Resource button and it will take us to the private DNS zone resource. And here on the left side, you will see an option called DNS Management. And within this section, let's click on the Virtual Network Links option. As you can see here, this is the virtual network link that we created as part of this private DNS zone. Okay, so far we have created the virtual network, and inside the virtual network, we have configured 3 subnets, the public, private, and the private endpoint subnet. And then we have created the private DNS zone specifically for the Azure Databricks name resolution, and then have linked the private DNS zone with the virtual network. So among the 4 networking concepts, we have created the first 3, and the last one we need to create is the private endpoint. So to create the private endpoint, we need to first create the actual Databricks workspace itself. And during that process, we'll be setting up the private endpoint connection. So the next step for us is to create a new Databricks workspace with the private networking configurations enabled. So let's see how we can do that. So to create that, let's jump back to our resource group, RG Private Network 01. As you can see here, these are the resources that we have created so far. And now let's create a new Databricks workspace. So for that, let's click on the Create button. And then let's check the Azure Services Only checkbox. And after that, if you scroll down, you can see the Azure Databricks service. So let's create a new one. Okay, now after checking the correct resource group, firstly, let's give a name to this Databricks workspace. So I'm going to give a name like DBW with private network 01. So basically, we created a Databricks workspace without private network enabled, and this time we are creating it with the networking configurations. So the name should represent that. Okay, after giving the name, let's go with the same Australia East region and make sure the pricing tier is selected as premium, since the private networking configuration is only supported in the premium workspace. So once this is done, let's go to the next tab, which is networking. So as mentioned earlier, in this tutorial, this is the most important tab. So if you remember something, Previously, we went with the default option while creating the Databricks workspace. And now, for this deploy Azure Databricks workspace in your own virtual network option, we need to select yes over here, since we are going to deploy this Azure Databricks to our own virtual network. So once you do that, it will ask you to select the virtual network. So let's select the virtual network that we created earlier, which is VNet DBW01. Okay, so we have selected our VNet, and now we need to fill in few details over here, which is the most important thing. Here you can see there are 4 required text boxes that needs to be filled. The public subnet and its corresponding IP address range, and then the private subnet and its corresponding IP address range. And above these 4 options, there is a note that says, implicit delegation of both subnets will be done to Azure Databricks on your behalf. So if you remember something, we have already created the public and the private subnet within our virtual network, right? And also, if you remember another thing, both these public and the private subnets have been delegated to the Azure Databricks workspace, right? So that's what exactly we are going to configure over here. In this, we are going to assign those 2 subnets in this particular Databricks workspace. So for that, we need to provide the subnet names and its IP addresses range over here. As you can see here, both these fields are required. So only when you delegate both subnets, you'll be able to deploy the Databricks workspace to the virtual network. Okay, so for doing that, let's jump back to resource group and open the virtual network that we created earlier. After opening it, let's go to the subnets menu. And here you can see the DB host, which is the public subnet. So let's copy its name and paste it in the public subnet name text box. And once this is done, we need to provide the public subnet address range. So for that, let's copy the address range from here and paste it over here. Similarly, we need to do it for the private subnet as well. So let's copy the name DB container and paste it in the private subnet name text box. And after that, we'll copy its address range and paste it in the private address range text box. Okay, so now we have delegated both the public and the private subnet to this Databricks workspace. So once this is done, if you scroll down to the bottom, you'll see something called private endpoints. So this is our 4th and the final networking concept that we are learning in this tutorial. As you can see here, there is a note that says, create a private endpoint to allow private connection to this resource. So basically, this is the place where you're going to establish a private connection to this Databricks workspace. So let's create a private endpoint. So for that, we need to click on the add button over here. Once you do that, firstly, we need to give a name for this private endpoint. So I'm going to name it as private endpoint DBW01. Okay, after giving the name, the next important thing we need to look into is the networking option. So to create a private endpoint, we first need to select the virtual network. So let's select our virtual network, which is VNet DBW01. After that, we need to select the subnet through which we are going to configure the private endpoint. Now, here is something interesting. When we click on the subnet dropdown, we can see an option called incompatible subnets. Among the 3 subnets we created earlier, the DB host and the DB container subnets shows up as incompatible. The reason for this is, if you remember, we have already delegated these 2 subnets to the Databricks workspace. The DB host is used for the control plane and the DB container is used for the compute plane. This means that we cannot use these 2 subnets for this private endpoint. So therefore, to configure a private endpoint, we need a separate subnet that is not delegated to anything else. That's why we created the private endpoint subnet. I think now you can understand why we end up in creating 3 subnets. Okay, so let's go ahead and select this private endpoint subnet for this. Once we are done with the subnet, here you can see the private DNS integration option. So basically, we need to select the private DNS zone that we created earlier. So why do we need this? So to establish a private endpoint connection, we first need a virtual network and a subnet inside that virtual network. We already have configured both. Now, when we communicate with Databricks using this subnet, we need a DNS zone to resolve the IP address. That's why we previously created the private DNS zone. And now we can select our private DNS zone, which is privatelink.azuredatabricks.net. After configuring this, we can click on OK over here. Nice. At this point, we have created all the 4 networking components. Firstly, the virtual network, and then the required subnets within the virtual network, and after that, the private DNS zone. And now we have configured our private endpoint using all the other 3 components. So this completes the networking tab configuration for our Databricks workspace. So let's go to the next one, which is the encryption tab. As I said earlier, we are not focusing encryption for this tutorial. So let's skip it and go to the next tab, which is security and compliance. So similarly, we can skip this tab and then the tags tab. And finally, let's click on the review and create button. Nice. As you can see here, the validation is successful. So let's go ahead and click on the create button. Okay, as you can see, our Databricks workspace is now being created with all the networking configuration enabled. So let's wait for it to complete. Nice. We have successfully created the networking enabled Databricks workspace. So now let's click on this go to resource button. Okay, so before launching this workspace and do the required testing, let's first look into few important things. The first one is, in the left side, you can find the networking tab under the settings menu. So let's click on it. So here you can see something called private endpoint connections. So let's click on it. And after clicking it, here we can see the private endpoint connection name along with its associated private endpoint resource. So this is the private endpoint connection that we created while creating this Databricks workspace. So now let's open this private endpoint resource. After opening it, in the left side under the settings menu, you can find something called DNS configuration. Let's open it. So basically, we all know this private endpoint is using this private DNS zone, which we configured while creating the private endpoint, right? In this private DNS zone, we have the most important thing, which is this IP address over here, which is 10.0.2.4. So this IP address comes from the private endpoint subnet's IP range. So what I mean by this is, here in the another tab, I have opened the subnet configuration for the virtual network. And here you can see the range of the private subnet address, which is 10.0.2.0/24. So from this address range, one of the IP address is assigned to this private endpoint over here, which is 10.0.2.4. Also, you can see something called FQDN, which stands for Fully Qualified Domain Name. So this is the domain name of the control plane. So in this domain name, you can see the Databricks workspace URI. And along with that, you can see the private DNS zone name, which is privatelink.azuredatabricks.net. So basically, the private DNS zone maps this fully qualified domain name of the control plane to its private IP address, which is 10.0.2.4, ensuring that all the communication from our compute plane to the control plane goes through a private IP rather than a public one. So this is exactly we are going to test with the newly created Databricks workspace. So for that, I'll just duplicate this tab first. And here, let's go to the resource group and open the newly created Databricks workspace, which is DBW with private network 01. After opening it, let's click on the launch workspace button. So similar to the initial testing, let's create a new compute for this workspace. So for that, I'll click on the create with personal compute option. And here, firstly, let's update the name to something like test private network. And after updating the name, let's change the auto termination time to 15 minutes. And finally, click on the create compute button. Nice. As you can see here, the compute is getting created. So while this is getting created, let's create a new notebook to do a similar testing as we did earlier. So here, let's update the name of this notebook to test private network. Okay, cool. So now in the other tab, I have opened the previous notebook, which has the test script. So we are going to use the same script in our newly created notebook for our testing. So for that, let's start with %sh to define the shell command. And after that, let's type the ns lookup keyword. And once this is done, let's copy the Databricks workspace URI and paste it next to the ns lookup command. So this is our complete script. And to run this, let's attach the compute that we created and go ahead and executing the script. So basically, when we execute the test script in the previous workspace, we got the public IP as an output. So as discussed earlier, this public IP address is used to communicate to the control plane that is deployed in the Australia East region. So now we are performing the same test through the networking enabled Databricks workspace to verify whether the communication is now happening through the private network or not. So let's wait for the script to run successfully. Nice. As you can see here, the output that this workspace produced has the private IP address, which is 10.0.2.4. And also if you notice the canonical name, this now has the DNS name, which is privatelink.azuredatabricks.net, whereas in the previous notebook, it doesn't have any private link associated with the canonical name. And also this private IP address, which is 10.0.2.4, is exactly what we've seen in the private endpoint configuration. For instance, I have opened the private endpoint service in the other tab, and as you can see, the IP address here is 10.0.2.4, which is exactly what we got in the output. Also, if you notice the fully qualified domain name, that's what we got as an output in the canonical name. So basically, this fully qualified domain name of the control plane is now resolving to the private IP address, which is 10.0.2.4 through our private DNS zone. Essentially, the private DNS zone is responsible for converting this domain name into its private IP address, ensuring that all communications between the compute plane and the control plane happens privately within the Azure backbone network. At this point, everything we set out to achieve is working correctly. All the configurations, virtual network, subnets, private DNS zone, and private endpoint are now in place, and the output confirms that communication is happening over the private IP rather than the public one. This shows the key difference between our initial setup and the current configuration. So if you look at the Azure Databricks architecture again, initially, the Databricks compute plane communicated with the control plane using a public IP over the internet. Now, with private networking enabled, the communication between the compute plane and the control plane happens entirely through the private endpoint inside the virtual network. So as per our current setup, this ensures there is no communication happening through public network, which significantly improves the security. This is exactly why we deploy Azure Databricks Workspace in a virtual network in real-time projects, so that sensitive or business-critical workloads never go over the public internet. Now that you should have a clear idea about what a virtual network is, what a subnet is, how your private DNS zone works, and how to configure a private endpoint. So if you look at this architecture diagram now, you can see how everything fits together. Here, the Databricks compute plane sits inside the virtual network, while the external service represents like a Databricks control plane. And we are trying to make a private communication between the compute plane and the control plane. So for this purpose, we created three subnets: the public subnet, which is the DB host, the private subnet, which is the DB container. So both of these are delegated to the Databricks workspace. And the final one is the private endpoint subnet, which is for making the private connections. So here, the private endpoint subnet is linked to the private DNS zone, which is privatelink.azuredatabricks.net. So basically, when we run any code inside the Databricks notebook, the private endpoint queries the private DNS zone to resolve the workspace URL into a private IP address, which is 10.0.2.4. Once the IP address is resolved, the compute plane and the control plane communicate over this private endpoint rather than the public internet. So this is the complete networking configuration that we have done for the Databricks workspace in this tutorial. I believe this step-by-step setup clearly shows how the entire networking configuration works in real time. So if you now look into the definition of these four networking concepts, such as the virtual network, subnet, private DNS zone, and the private endpoint, everything will make much more sense now. So if I simply tell you the concepts directly, you might not fully understand them. That's why I have given such a detailed step-by-step explanation so you can see everything in real time and understand how it all works together. My main goal is to simplify complex topics so anyone can follow along easily. I believe I have explained the concepts in the simplest way possible, and I truly hope this tutorial has been helpful to you. If you want me to explain more complex topics in the same detailed manner, please subscribe and leave a comment. Your comments and support will definitely motivate me because it shows that the effort I put into making this tutorial is appreciated. Okay, now, before we wrap up, there is one important final step that we need to do, which is deleting the resource group we created for this tutorial. The reason is very simple. These resources cost money. So if you keep them running after the tutorial, you might end up paying more than you expect. So to avoid unnecessary costs, always delete the resource group once you have completed the tutorial. As you can see here, I'm deleting the resource group directly. It's quick and easy, and it ensures you won't have any surprise charges later on. I hope everyone will do that. Finally, if you enjoyed this tutorial and found it valuable, please like, share, and subscribe. Your support means a lot, and it motivates me to keep creating practical real-world tutorials like this. So that's it for today. See you in another great video. Until then, cheers. Bye.